binomial radical expressions. Today we're going to add and subtract radical expressions, we're going to multiply binomial radical expressions, and we're going to multiply the conjugates of radical expressions in order to eliminate the radical. This lesson is in preparation for REI2, where we're going to be solving rational and radical equations. Before we get into that, and a quick review of simplifying, here we have the cubed root, and a cubed root means I need 3 of the same things. In order to do that, I'm going to take the 64. I don't know what the cubed root of that is off the top of my head, but I know I can break that down. Now I need 3 of each, so I have 3 2's right there, and I have another 3 2's there. So outside the radical, I'm left with 2 times 2, which is 4. Now remember, for the variables, the fastest, easy way of doing that is the division method. Divide the exponent by the index. So 12 divided by 3 is a to the 4th. 15 divided by 3 is b to the 5th. And 18 divided by 3 is c to the 6th. And we have our answer. Always make sure you check your answer so you can get it right. Adding and subtracting radical expressions. You can only add or subtract like terms. This doesn't matter if you're dealing with a variable or if you're dealing with radicals. Remember, when you're adding like terms, you only add or subtract coefficients. Coefficients are the numbers in front. Now, we normally refer to numbers in front of a variable, but it works for radicals also. So I have like terms. They're both the square root of 7, and I'm simply going to add the coefficients, or the numbers in front. Just that simple. Now for the next one, I have a whole bunch of different numbers. So what we want to do is look for our like terms. Our like terms have the square root of 3x. The square root of x is different than a 3x, and in the 4 he has nothing. So we're going to combine those like terms, and then the other 2 terms cannot combine, so we leave them alone. For the next one, they try to trick you. They give you the square root of 3, and then they give you the cubed root of 3. These are different. You cannot combine them. So you're going to leave them alone. They're not like terms. We can't change them. Just leave them alone. The next one, they are like terms. They're both cubed roots, and so we can combine the numbers in front, giving us 5 cubed root of x squared. Now, if needed, simplify first. At first glance, this problem doesn't look like it has any like terms. However, I can also see that these are not simplified. The square root of 125 can be simplified to 5 radical 5b. The square root of 20 can be simplified to square root of 5b. And we got the 6 in front by multiplying 3 times 2. And then the square root of 45. So if we notice, they are all like terms, 5b, 5b, and 5b all the way down. All you have to do is combine the numbers in front, giving you 8 square root of 5b. Again, simplify first. Pause the video and see if you can get this one on your own. And this should give you 7 square root of 2. Remember, when multiplying radicals, you multiply the inside times the inside and the outside times the outside. If you need to review this, check our last video lesson, Simplifying, Multiplying, and Dividing Radical Expressions. So for example here, the insides are 12 and 15, and the outsides are 2 times 3. That gives us 6 square root 180. But then I still need to simplify 180. Now here's a trick. Instead of multiplying them first, try simplifying first. I see 12, and 12 can break up in 2, which will give me 4 square root of 3 times 3 square root of 15. This is going to make my life easier in the long run. Again, I multiply. Now, it's a lot easier to simplify 45 than it is 180. When I simplify 45, I can take out a 3, which gives me 36 on the outside, square root of a 5. We would have ended up at the same place. However, it's a lot easier to simplify first. Now, let's expand that a little bit. If I have a monomial times a binomial, this is basically distributing. Don't forget, when you distribute, to use your lines, and then this should be elementary. Now, here's a trick. I need to multiply 14 times 14. I'm going to leave that as a 14 squared. And then I have Why did I leave that 14 squared? Because I know that the square and a square root cancel each other out. So I don't really care that 14 squared is 196. What I care is that I can take the square root of 14 squared very quickly and easily and get a 14 on the outside, and the y is left on the inside. Similarly, I have the square root of y squared. Well, the square root of y squared simply becomes y with a 14 on the inside. Now, if you don't remember how to multiply binomials, I strongly suggest going back to the video we did yesterday, multiplying polynomials. But here's a quick rundown. We multiply binomials the same way that we multiplied in elementary school, on top and bottom. It should look something like this. Just like we did in elementary school, we multiplied the 1 up to 3 and 4, put a placeholder, and multiply the 2 up to the 3 and the 4, and then at the end, always add. We do the same thing with the binomials. Now, this should look familiar. If it doesn't, go back and review that video. Don't forget to always put your like terms in the same column. Now we're going to do the same thing with radicals that we did with the variables. Nothing is changing. Set up your problem on top and bottom. Then multiply the 1 up to the 3 root 5 and to the 4. Don't forget your placeholder. And multiply the 2 root 5 up to the 4 and to the 3 root 5. Now the key here is to make sure you put like terms in the same column. Then combine those like terms. Now, here's the difference. I have the square root of 25. That can be simplified. The square root of 25 is 5, which gives us 6 times 5, which is 30. Now I have 30 plus 11 square root of 5 plus 4. Again, I have another set of like terms. The 30 and the 4 should be combined, which gives me a new complete answer of 11 square root of 5 plus 34. Here's another one. It looks more complicated because there's 2 sets of radicals, but it really isn't. Set it up the same way, and then go and start multiplying. Make sure you notice positive times negative is a negative, and that gives me 63 square root of 4. We'll simplify that in a minute. And then negative times a positive again is negative 18 square root of 10. The key here, make sure you're paying attention to your positives and negatives. That's an easy place to get messed up. Now we'll keep multiplying. Then we're going to multiply the square root of 5 straight across. Remember, inside times inside and outside times outside. Since there's only an invisible 1 on the outside, we get 1 times 7 is 7, and 5 times 2 is the square root of 10. And do it again. Then we can combine like terms. At this point, go ahead and start simplifying. Negative 63 square root of 4 simplifies to negative 126, and then 2 square root of 25 simplifies to positive 10. They are like terms, so you need to combine those, which gives us a final answer of negative 11 square root of 10 minus 116. Now, people have a tendency of struggling with squares, and what they do is they distribute the square through, which is completely and totally wrong. Remember, what does a square tell you? The square tells you that you're multiplying the one binomial times itself. Now, this one's a little more complicated because it has a binomial inside a binomial, but we'll see how to take care of that easily. Set this up the same way you set up all the other binomials. Then multiply, again, the same way we did all the other binomials. Don't forget a negative times negative is a positive. And then multiply the other piece also, giving us a second negative 4 root 2x plus 3. Now, this is the tricky part on this, and it's going to make your life a lot easier. When we multiply 2x plus 3 times 2x plus 3, don't actually go through all of the work of multiplying it. It's not needed. Write it like this. We're going to have the square root of, when we multiply the insides, it's going to be the same thing multiplied times itself. Well, what's the same thing multiplied times itself? It's a square. That's going to give us 2x plus 3 squared. Now, you could multiply that out if you really wanted to and get 4x squared plus 12x plus 9, but that's not needed. Watch this. We're going to combine like terms like we normally do. And then when we go to simplify, you should note that a square root and a square cancel each other out. What that means is that our final answer is simply going to lose that radical, giving us a 2x plus 3. We also have that positive 16 over here. Now I see some like terms that need to be combined. I have a positive 3 and the 16 that are like terms. We can combine them. The 2x is not a like term with anybody, and the negative 8 with the square root behind it is not a like term of anybody, so they're going to be on their own, giving us a final answer of 2x minus 8 square root of 2x plus 3 plus the 16 and the 3 gives me 19. So when we multiplied two binomials, we ended up with a trinomial. That should sound kind of familiar. Here's one more perfect square. This one is written backwards with the x on the outside. So pause the video, try it on your own, and then check back to see if you got it right. That leaves us with x squared plus 2x squared root of 2 plus 2 as our final answer. Notice I wrote this x squared in front and the number in the back. We always write these in descending. Moving on to multiplying conjugates. This is a way to cancel out the radical. How does that work? Well, if you notice in the last couple examples, the radical was our middle term. So here's our middle term, we kept the radical. Here was our middle term, and we kept the radical. So for multiplying conjugates, think of a difference of two squares. When we multiply a difference of two squares, that middle term cancels out. For example, when I multiply the difference of two squares, the 28t and the negative 28t cancel out, giving me 16t squared minus 49, basically giving me the perfect squares. That is multiplying conjugates. Here's your example. I have 6 minus the square root of 12 and 6 plus the square root of 12. Just like in the last example, we have a plus and a minus with the same exact thing. That's a conjugate. Plus and minus with the same exact expression. Set them on top and bottom just like normal. Then start multiplying just like normal. Forget your placeholder, and then keep multiplying. Final step is to combine like terms. Now, important as always, we have negative signs here. Make sure you're following your negatives. Positive times negative gave me a negative 144, and positive times negative gave me the negative 6x. When combining like terms, the positive 6 and the negative 6 cancel out, giving me 0 square root of 12. Well, 0 times any number is just 0, so we don't write that. And then we bring down the 36. Now you should see that the negative square root of 144 can be simplified to give me 12, which gives me a final answer of 24. Now, some of you are saying, well, did we need to multiply the 144? No, you didn't need to multiply the 144. If you would have preferred when we did the square root of 12 times the square root of 12, and you just wanted to write 12 squared so they can cancel, that's perfectly fine. That would work. Here's another one. We know it's a conjugate because it's the same thing, positive and minus. Pause the video, try to figure it out on your own, come back, make sure you did it right. Again, make sure that you are careful multiplying with your negatives. Don't forget your negative, and be sure that you are multiplying inside times inside and outside times outside. Your final answer after you simplify should come out to 47. Now, you didn't think they'd all be that easy, right? Here we have a conjugate, but there's a binomial on the inside. Doesn't matter how big and ugly these get, just follow the same rules. Put them on top of each other, and then multiply through. Again, like the other problem, I'm not going to multiply out 3x plus 7 times 3x plus 7. I'm simply going to put a square there because we know that it's going to cancel out later. Positive 9 and negative 9 cancel out to give me 0, which cancels out the entire middle term. And then, like we just said, the square root and a square cancel each other out. That's going to give me 81. Now notice this negative sign. The negative is still on the outside. So that's going to become literally negative times 3x plus 7. Don't forget to distribute that negative sign through. That is a key point. If you don't distribute that negative, you will get it wrong. It gives us an 81 minus a 3x minus a 7. Now I still have like terms, the 81 and the negative 7, which gives me a final answer of negative 3x plus 74.